Next concept is called as the divisibility test. Okay, divisibility test basically deals with uh, checking off. Let's say there is a number and we want to check that whether that number is divisible by say 2 or 3 or 4 or right 5 up to 9 or any other number, any other prime numbers as well. Okay, so let's say that yeah, okay, let's deal with the what is the divisibility test and what are the conditions. Let's try to discuss that first, then we'll see how it can be extended further. Okay, so in decimal system, decimal system, all uh, all the numbers are formed simply by using the digits 0, 1, 2, 3 up to 9, 0 to 9. Right. Now let us consider, right, the highest number what we might consider is say a 5-digit number. Let's consider a 5-digit number. Okay, let A, B, C, D and E, right, is a 5-digit number, right, in decimal system, right? So that means if I write A, B, C, D, E, right, can be any 5-digit number. This can be simply written as 10 to the power 4 times A plus 10 to the power 3 times B plus 10 square into C plus 10 to the power 1 is 10 into D plus 1 into 10 to the 0 into E. So this is how we represent. Right. Now, I want to check whether the 5-digit number is divisible by, right, 2, 4, 8, etc. Okay, I want to find this. Right. So, right. Okay, let me write the A, B, C, D, E is a number, right? Any number will be divisible, right? I'm checking the conditions below this, right? So the first one is it's divisible by 2, right? How do you check that? I know that if it is divisible by 2, right, if and only if the last digit, that is E, is divisible by 2. Last digit you check and it's even or odd. If it is even, yes, you can divide, it can be divided by 2, otherwise no. Very simple, right? So let's go to the next condition. This is divisible by 4. Right? What is the condition? That is if 2 times D plus E, multiply whatever D you see into 2, right, plus E. Perform this. If this answer is divisible by 4, if it is that, then yes. Okay, say for example 24, right, whatever is the number, you take that last 2 digits are 24. Right? So 2 into 2 is 4 plus 4, 8. 8 is divisible by 4. That's why 24 is divisible by 4. Very simple. Then my next condition is divisible by 8. How do you check whether a number is divisible by 8? That is if 4 times C plus 2 times the D plus E. This should be divisible by 8. Okay, all right. Then let's try to go for a any other number which is 2 to the t. Okay, is divisible by say 2 to the t. 2 to the t indicates 2 to the power 4. That is 16, right? I can check that whether a number is divisible by any 2 to the t. Can be varied. If you put t as 4, this becomes 16, right? I can simply check, right? If you want to check that whether this is the case, whether the number is divisible by any 2 to the power t, right? So the answer is yes, if, right, the number formed, if the number it is, if the, sorry, okay, if the number formed by the last t digits, right, is divisible by 2 to the t. Okay, right. For example, let me give an example for this one, the most recent formula I told. So I have a number like, in this case, it is not required to have only 5 digits, right? It is any number, right? Say 82010 and 1280. So this is my number. I just want to check that whether this is divisible by a number which is 2 to the 5. Right, 2 to the 5 is 32. I just want to check whether this number is divisible by 32, right? So 32 means it is 2 to the 5. So when I have 35, 32, I can write it as 2 to the power 5. So is divisible by 32, I want to check. I'll write that number as 2 to the 5. So it says that if you have a 2 to the t, right, just form a number from the last t digits of the given number. T is how much, right? This implies 2 to the 5. This implies t is equal to 5. So extract 5 last digits from the given number. So what is the 5 last 5 last digits, right, is 01280, right? I just have to check whether this is divisible by 2 to the 5 or not, right? So this is actually divisible by 2 to the 5. Okay, this means it is divisible. So the answer is yes, right? Whether the given larger number is divisible by or this or not, you can say that yes, it is divisible. All right, then let's proceed further. Next, continuing the same points. So I just want to check whether it is divisible by 5. Right. So the answer is yes, if E is equal to either 0 or E is equal to 5. Last digit is 0 or 5 means it is divisible. Yes, we know that. Right. Then any other number which is a 5 to the power. So this is 5. Okay, I can write 5 to the t. So I want to check whether it is divisible by 5 to the t. So here the answer is yes, right? If the number formed by the last t digits is divisible by pi to the t. Same thing which we did so far. Okay, so that's fine. Then I just want to check whether the number is divisible by 3. Okay, this is yes if the sum of the digits a plus b plus c plus d plus e, this sum, right, is divisible by 3. Then I just want to check whether the number is divisible by 9. Okay, this is true if once again the sum a plus b plus c plus d plus e is, right, divisible by 9. Okay, next one, I just want to check by 6. If you want to check that by 6, if the number is even, if the number is even and divisible by 3, whichever number is even and divisible by 3, they also get divisible by 6. Okay, then just want to check, right, if a number is divisible by 18. Okay, so the condition is if it is, or the if the number is even and divisible by 9. Okay, then my next condition is I just want to check whether the number is divisible by 7. Okay, so this is if a b c d minus 2 times e. ABCD is a product. Okay, first 4 digits take a product, subtract 2 times the last, right? This answer is divisible by 7, means the total number is divisible by 7. Okay, my next condition is it divisible by 11? Okay, so sum of the digits in the odd places, that is a plus c plus e minus, right, you have to perform the odd places minus the sum of the even places, that is b plus d. This answer, right, is divisible by 11. If that is the case, yes, your answer is divisible by 11. Okay, so I'll give a number, just check that quickly. Right, so the number you have to check now is 1 5 2 2 2 1 6 3. Right, my question is whether this number is divisible by 11 or not. So the calculation that we are going to perform is 1 plus 2 plus 2, 1 plus 2 plus 2 plus 6, odd numbers, odd index numbers, minus the even index number, that is 5 plus 2 plus 1 plus 3. This answer comes to be 0, right? So 0 is actually divisible by 11, right? So 11 into 0 is 0. So it is divisible by 11, means yes, the answer is divisible by 11, right? Okay. The last one we want to check is whether a number is divisible by 13. So that is possible if A, ABCD plus 4 times E, right? That is divisible by 13. If that is the case, then your answer is yes. All right. All right. Let's move on to the concept of permutation. Okay, now this is going to deal with each of the different arrangements that we can make by taking some or all of the number of things. Okay, it is called as a permutation. So let's try to write a simple definition for this. This is each of the different arrangements which can be made by taking some or all the number of things, all right, is called as a permutation, right? So you see, in case of a permutation, the order of the arrangement, order of the arrangement is very important in case of a permutation. All right. Now let us try to write one very important result. Right. So the number of permutations of, say, n different things, comma, taking r at a time, right? This is actually denoted by n, p for permutation, and r. This is also denoted by, some of the textbooks will say, permutations of n comma r. So what is the calculation? How do you represent that? So this is most preferred one. NPR is equal to, right, n factorial divided by n minus r factorial. So we know that n by r, if at all I have a term like this, you can refer the properties of, right, the representation of factorial. You can refer that, and we have an answer here. So that is equal to n into n minus 1 into n minus 2 into n minus 3 up to the last term being n minus r plus 1. Okay, so that is the general representation. Okay, then let's go further. There is another concept related to this. So the number of permutation of n different things taken all all at a time. So that has to be NPN, right? NPN is nothing but this is simply n factorial. One very important property, right? Then if at all you have to substitute somewhere NP0, simply replace that as 1, okay? And if you have to substitute somewhere NP1, right, that is nothing but n, okay? And also if you have to substitute NP n minus 1, that is also always equal to NPN, which is nothing but n factorial. Just remember. Okay, then we have another formula to remember. If at all I have NPN being represented as, okay, not NPN, my mistake. Let me write NPR. Okay, so if I want to perform NPR, that is equal to n times, I can write it as n minus 1 p r minus 1. Okay, so I can try to write it in this way: n minus 1 p r minus 1. Then this is also equal to, I can rewrite this as n into n minus 1. Okay, that is n into n minus 1 times, this is n minus 2 p r minus 2. That is also equal to, I can write one more term, n into n minus 1 into n minus 2 into n minus 3 p r minus 3, and so on. I can extend this. Okay, that continues. You can even write n into n minus 1, n minus 2, n minus 3 into n minus 4 p r minus 4, and so on. Okay, then there is another property to remember, that is n minus 1 pr is nothing but, this is simply n minus okay, this is n minus r. Okay, this is n minus r into n minus 1 pr minus 1. Another property, n pr divided by n p r minus 1 is simply n minus r plus 1. All right, then let's go for some of the common questions that are asked from the concepts of permutation. Right. So if 56p r plus 6 to 54p r plus 3 is equal to 30,800. All right, so find RP2 is how much? Okay, now, so let's try to write what has been given. So they have mentioned that 56p r plus 6 divided by, this is 54p r plus 3 is equal to 30,800. Given data, right? So I can make 56p PR plus 6 into 54, provided I can try to eliminate two terms from that, right? So this is equal to 56 is there. So 56 is 56 into 55. If I remove that, this becomes 54. 54 PR plus 2, right? Just remember, I'm trying to apply one of the property which we have seen just now. Okay, my mistake, I think. This one. I'm applying this. NPR is n into n minus 1, n into n minus 1. This is what I'm applying. I have to subtract n as well as r by 2. Okay, I think I didn't subtract r, right? Okay, let me subtract r as well from this. Okay, so this is what I'm trying to do now. So this has to be 56 into 55 into, this is 54, because 2 has been reduced. Even the r has to be reduced by 2. R is actually, you have r plus 6. So the r plus 6 becomes r plus 4. 54 p r plus 4. Reduce this, right? So you had r plus 6, right? The r plus 6 becomes r plus 4, because I am reducing 2 of them. So 56 became 54. R plus 6 becomes r plus 4. All right. So this is what in the numerator. Denominator, let me keep this same. So this is divided by 54 p r plus 3 is equal to 30,800. Okay, 55 into 56 is 3080. So this cancels this with the 10 times. Now apply another formula, right? The formula which you are going to use now is this one. NPR by NPR minus 1. So this is NPR, this is NPR minus 1, right? R plus 4 and R plus 3, they are different. There is one difference among them. There is a difference of 1. So that formula I can apply, right? So this means this is equal to, you can n minus R plus 1. So I can directly write, this is nothing but, I just have to write n minus, n is how much? 54 minus r is equal to r plus 4 plus 1. So that should be equal to 10. So I have all the values required to calculate r directly. So r is equal to, r goes to the other side, right? So this is 54 minus 10, that is 44, minus 4, that is 40, plus 1. So r is equal to 41 is the required answer. I think it's not just r, I think they are asking rp2, right? Okay, so what is rp2 is the question. So the answer I'm supposed to find out is, right, 41 p2, that is 41 into one number lesser than that, 41 into 40, so 1640 is the required answer. Okay, right? So this is important. Next question. If n plus 5 pn plus 1 equals to 11 times n minus 1 divided by 2 times n plus 3 pn. Okay, if that is a case, find n is equal to how much? This is the question. Okay, so the solution is, whenever you see two of the something like NPR, you try to bring it into the same side so that you can apply some of the properties, because most of the properties have those terms on the same side. Okay, let me write this. N plus 5. This is N. Okay. So this is N plus 5 Pn plus 1 divided by N plus 3 Pn should be 11 times N minus 1 by 2. Apply the property and make this also N plus 3 somehow. Right? So the properties is, if I have NCR, I can write it as N into N minus 1. And every time I reduce, I have to reduce the N as well as R. Okay, now, so therefore, let me try to reduce the terms and bring it into the required format. So this is N plus 5 I have. When I have N plus 5 and I try to reduce, right, this is N plus 5 into N plus 4. N plus 5 into N plus 4. Now what remains is N plus 3 P. The N plus 1 also should reduce by 2. You get N plus 1. Not N plus 1, my mistake. N minus 1, right? N plus 1 becomes N and N minus 1. So this becomes N minus 1. Denominator is still N plus 3, right? P N. This is still equal to, right hand side, I'll still keep the same thing. This is 11 times N minus 1 divided by 2. Now you see, just now we applied one property, right? Something like this. R plus 4 and R plus 3 can be written simply like this, right? So if the numerator has highest and denominator has the lesser one, then the answer comes in the numerator. But now you just check, the current situation is slightly different. So in this particular problem, I have the bigger term in the denominator and the lesser term in the numerator. N in the denominator, N minus 1 in the numerator. So because of which my answer comes into the denominator. Answer is same but comes into the denominator. Numerator still have N plus 5 into N plus 4. Denominator is nothing but the N is nothing but N plus 3 minus the R value is N plus 1. Okay, so that is the term. I'm applying the equation n plus 3 minus n plus 1. Equate. Right side is 11 times n minus 1 by 2. Okay, I think we can simplify this directly now. So this is n minus n cancels. So 3 minus 3 plus 1 is 4. So this 4 cancels with the 2 as this 2 cancels with them as a 2. This 2 goes to the other side as 22. Okay, so 11 is already there. So you have a 22 coming up. So my final equation is n plus 5 into n plus 4 is equal to 22 times n minus 1. I guess. Okay, now you see it is very simple format. Just solve this equation and find the value of n. Upon solving this, we find that n is equal to 6 or n is equal to 7. So 6 and 7 is the right answer. Next question. If n plus n P2 equal to 90 and n minus n P2 equal to 30, find the values of m and n. So when we solve, we get one of them, maybe the bigger one as 8 and the smaller one as 2. Okay, that is the correct answer.